Hello guys and welcome to the Northern Panorama channel. Today we will do some narrowband processing of the IC1805 Heart Nebula. Data that I collected with the ZWO 1600 about 2 years ago. So I will process in PixInsight and Photoshop from start to the end. So first I will open the stacked files in PixInsight. So I just drag them over here. And the first thing I will do is to change this identifier. And this is the sulphur-II, so I just name it S. The oxygen-3 will be O. And the hydrogen alpha HA. And then I will use this screen transfer function, the auto stretch, and I will press command and click this to enter the unlinked mode. So this is only for to stretch the image on the screen. It will not affect the data. And as you can see, there are some stacking artifacts around here, so I have to crop these images, and I will use the dynamic crop tool here. And yeah, it's not that exact on this target, but something like this. And then I just drag it to the other subs here. And okay. The next step I used to do is to run the Graxpert background extraction to remove if there are some gradients. It also creates a new version here, so I will change this one also to HA1. And this is a background that is removed a little bit of gradient, so we close that one and run this on each of one of these. Okay, so now we have this 3 narrowband subs, and or not subs, these are stacked files. The next thing I will do is to prepare for the stars, because narrowband stars used to look pretty ugly. So if you don't have had time to shoot RGB stars when you're out, you can create RGB stars from this data, and I used to use PixelMath. Here we have this, and I'll check the single RGB expression and open this, and then I have a formula 0.4 times hydrogen alpha, and it's HA1 in this, and plus 0.6 times sulfur, and it's designated to S1. The green channel is 0.4 times O plus 0.3 times hydrogen alpha plus 0.3 times sulphur-II. And the blue channel is just oxygen 3. And then press OK and open the destination here, and we will create a new image, and the color space should be RGB. Okay, and then just drag this over to any of these files. And now we have an RGB, combined RGB image here, and I will auto stretch it and change this one to RGB. And what we will do now is to solve this. So I go here to Astrometry Image Solver and put in the target IC 1805. Does not. Oh, sometimes it shows other. We have, and the pixel size on the camera 3.76 micrometer, focal distance and resolution. Just press OK. Yes, I want to continue anyway. And now it will tell PixInsight which target this is. So it's now downloading data and do a plate soap process. And there we have it. So now I have told the program where what I have shoot at, and now I will use the spectrophotometric color calibration to calibrate the star colors. Here it's possible to choose some kind of region of interest, but there's so lot of nebulosity in this one, so I just leave it as it is. Okay, so now it has calibrated, and as you can see, it deviates a little bit here, but overall it gives stars that are significantly nicer than using stars directly from the narrowband data without combining them and create an RGB image. So we can close that one, and now I will choose Shift to the linked auto stretch. This one we don't need, so I can close that. And here we have calibrated as good as it's possible from narrowband data image. And it's the stars that I want here. So the first thing I will do now is to make them a little bit tighter. So I will run blur exterminator, just the default values here. Okay, much nicer. And now I will generate a star image with a star exterminator. Okay, so here we have the background without stars. I will not use it. And here we have the star layer that I will stretch later and use in Photoshop together with these images. Okay, back to the narrowband data. I will run star blur exterminator on each one of these. I will not use the stars from these files, but it will also sharpen up the background a little bit. Okay, and now we'll delete stars from this. And you can see the difference in noise between these images. So the sulphur-II channel and the oxygen-3 channels are pretty noisy, and the hydrogen alpha looks quite good. So I think it is around 1.5 hours each of these ones, so around 4.5 hours in total. So now I will stretch these files, and there are different methods to do that, but I will use now the statistical stretch, which is quite easy to use. We can begin with hydrogen alpha. Press preview, refresh. We'll boost the curves a little bit and take that down. And try something like that, and press execute to stretch it. Then I will choose the sulphur-II. Yeah, something like that, and execute. And then we have the oxygen-3. Looks pretty bad, but in the end, I think it will be quite good. Try there and close it. Now I will combine these files, and then I will use LRGB combination, and I will assign hydrogen alpha to the luminous and green channel, and oxygen 3 to the blue channel, and sulfur to the red channel. And then we can minimize this. And when I press here, it will create a combined image, and it looks okay, but not it's very greenish. So what I will do is to run the narrowband normalization, and open up the preview window here. And now I'll change these sliders. Something there. Sometimes I used to do this in steps and see what's happening. A little bit too much of oxygen 3 boost. And now it becomes a little bit, goes to the greenish. Maybe not something like that. And here you can also try with the other settings here. So you can try to see what's happened if I pull down the oxygen yeah, it gets even more. So you have to experiment and try different settings and move these sliders. This is not real colors, it's false color astrophotography. We have mapped invisible gas distributions to RGB channels. So you have a lot of creative freedom in this with this kind of processing. So now we have two images here, and we can take this one further, and yeah, I would like to bring up the saturation a little bit and try to make it a little bit more yellow goldish here, and maybe get rid of some of the bluish and reddish around here. So what I will do now, I will create a copy, a clone. I just drag it this one to the left here, and now I have a clone, and I will with this one create a mask. So I'll use the ACDNR filter here and the lightness mask, and open up a preview window and box this preview also. And here I can adjust these sliders. Well, try something like that. And then now we have a mask that I will apply on the image. I put it there. And this is how it looks when you can see which areas that the mask is affecting, but we can unbox here, show mask, so we have the image as it is, and then I will use the curves transformation tool here and open up a preview window, and I can just yeah, you can see which areas that affects, and it's the outer parts here. So I go into the blue channel here and bring it down a little bit, and then the red channel. Something like that. and then I will invert the mask so we can do some changes in the central parts here, and I would like to pull up the reds a little bit in the highlights. And pull up the saturation a little bit. And the chroma. What I'm trying to achieve is to bring out the yellow goldish tones here, and to have some blue tones in these parts. And also apply a little bit of an S-curve here. To make it to add some contrast. And this is a part where you can experiment quite a lot. Okay, we have something that start to look like what I'm about to look as what I'm want to achieve. So we remove the mask there, and I will then you can see there's it's quite a lot of noise here in the image. I will apply some noise reduction with a Grexpert denoise tool. If it takes some time here. Okay, so this one I will save. Lot 15 RGB. It's October 21st today. And I save it as a 16-bit tiff file. And then we need some stars also. So we go back to this file that I created from with the help of PixelMath from the Narrowband images. So now I will stretch the stars, and I use star stretch from ZWO Astro. And I used to go down here on the stretch amount, maybe 3.44 is okay, and then bring up the color boost quite a lot here. Refresh preview. I can see if the stars gets a lot smaller and more tight. So I execute, and now we have the star layer that I will apply in Photoshop. I used to write the stretch amount in the file name for the stars, so I remember if I need to or want to change it. Save it as a 16-bit TIFF file. Okay, so now we will continue process these files in Photoshop. So I open up Photoshop, and here we have the background, and I will copy the stars to a separate layer and choose linear dodge here. You can choose screen, color dodge, or linear dodge. I used to use linear dodge. So now we have stars there, but it looks pretty pale, a little bit washed colors. So we will process it further now in Photoshop. And the first thing I often do is to do some additional noise reduction with topaz denoise. And here you have to be quite careful because you can overdo it. So now I use low light AI model and turn down it a little bit, and also bring down the sharpness a little bit, but I think that will be fine. And then I create a new adjustment layer and will change the levels for each channel here to make it pop a little bit. Yeah, maybe something like that. You can see the difference. And with the stars, I will then use saturation and first choose yellow here and bring up the saturation a little bit and maybe change the tone a little bit, adds a little bit of red. Mm. Okay. One thing I often do is to add sharpness in different stages in the process, and here I will bring out some details even more, but I don't want to affect every part of the image, just these parts in the Milot 15 and some other parts that I want to be a little bit more sharp. So I copy the background and create a new image here. Oh. Copy and paste it here. What happens there? It's okay, there. I flatten this and choose from RGB color to lamp color, and I duplicate the layer and go to channels and choose the lightness channel. And in the lightness channel I will apply unsharp mask, and as you can see it adds quite a lot of sharpness here. Quite large radius here, 2.8, and can play around with this and see what suits your images, and amount around 200. Okay, and go back to the layer, and I don't want it to affect every part, as I said. So now I will create a layer mask and hide everything, and choose a white brush, and I have a flow at 26%, and now I will just paint in the layer mask here the areas that I want to add sharp. And this is also something where you have to be a little bit sensitive, because it could be too much. Okay, and flatten image, and copy this, and paste it as a new layer here, and I rename the layer to lab sharpness, so I know what I have done there. It's also possible to, if you want to add some saturation, we could also, in this lab image, choose new adjustment layer and curves, and then I choose the A channel. I bring this one to 90, and this one also to 90, and then choose the B and do the same. And now you can see that it's a lot more saturation in the image. So maybe too much, and you can just change the opacity here. With 50%, and can flatten it and copy this one also to this image, and now you can see it brought out the colors even a little bit more, but maybe too much. So we can bring down the opacity here also a little bit. So I can adjust the color balance, the shadows. To what you think looks good. The highlights, I want to bring out the yellow tones here and the reds a little bit. In the mid-tones we can bring out a little bit of the blue. Yeah. Here we have the stars. RGB stars. I will duplicate this layer and use camera raw filter, and here we can maybe add a little bit of clarity on vibrance and saturation, bring down magentas, purples and greens that we don't want to have, and maybe add a slightly amount of sharpening to the stars just to make them a little bit tighter. Okay, so now I think I'm basically down to, clear with this image. I have done some noise reduction, sharpening. I have adjusted levels. I have brought out a little bit of saturation and adjusted the star layers. So now you can just export this image and save it as in the format that you want. So I think that was all for now. I will soon go out and shoot at remote locations again. Let's wait for some clear skies. And if you like this video, smash the button down there and start to follow my astrophotography adventures.